last 2 pages of integration here, and the last few pages you've been just doing integrals, which means you've been finding the antiderivative function of the function they've been giving you. And the last 2 pages here, we're actually going to be finding numbers for the integrals. And physically, that would correspond to the areas under the curves that they're giving you. So they're giving you a curve, then you find the integral function, which is a function which can give you the area at any point, and then we're actually putting in numbers saying, okay, I want to find the area from x equals 3 to x equals 5. What exactly is that area? The answer is 6 or whatever. It's good. They're going to give you an exact number. And these are called definite integrals. They're called definite integrals because they are definite quantities or numbers. They are not just functions. This symbolic expression here can be read as the integral of f of x with respect to x from x equals a to x equals b. So this part here, f of x corresponds to this, right? This part dx corresponds to here with respect to x. The integral, of course, is this symbol here. And then finally, at the end, it says from x equals a to x equals b, it's talking about these limits to the integral, the left limit, the right limit, the lower limit, upper limit. Okay, so now we're going to proceed on to doing integrals. And so the first part is going to be exactly the same as the last few pages. You're just going to be finding the integral function. And then after you do that, then you're going to make it into a definite integral by using the values of a and b, except for they're not going to be a and b, they're going to be numbers. And then you're going to get a definite number out of it. Okay, so let's see. First we got, they're giving us 2 similar integrals, and then you're going to discover what the difference is between, like here you have the function x, and here you have the negative of the function x, and you're going to see what you get as a result that's different. Okay, so first we're going to do the first one, and we're going to rewrite x, square root of x is x to the 1/2. And then the integral of x to the 1/2, of course, is x to the 3/2 times 2/3. And then we're going to evaluate it from x equals 1 to x equals 4. And that would be equal to, we're just going to put 4 into it first. 4 to the 3/2. And then we're going to subtract the the one we put in 1. Sorry about the writing there. It's a new pen. It's a little bit too hard, I think. Okay, so then we have 4 to the 3/2 is actually 4 square root, right? Square root, which is 2, and then you cube it, 8. So it would be 2 times 8, 16/3. Okay, and the next one, 1 to the 3/2 is just 1, right? So it would be minus 2/3. So the result is 14/3. Okay, so that's the answer to the left one here. The right one is the same thing, except now they have a negative sign in front of it, so the integral function, instead of being 2/3 x to the 3/2, is going to be negative 2/3 to the x to the 3/2. And it's the same limits of integration. It's going to be 1 to 4. So now you can see that it's going to be just like, instead of being 16/3 minus 2/3, it's going to be negative 16/3 minus 2/3, which plus, minus a negative 2/3, it's going to be plus 2/3, which is going to give us negative 14/3. So you can see that when you have this and when you have this, the results are going to be negatives of each other. So we could say, hey, look, 1 through 4, square root of x, or actually we could just say, in the general case, we could say f of x dx is equal to the negative 1 through 4 negative f of x dx. So if you put a negative in here, it's just going to give you the negative result. All right. Now here in number 3, they give us 3 different integrals that are all kind of similar, except for this one goes from 0 to 2, this one goes from 2 to 3, and this one goes from 0 to 3. Okay? And if you keep in mind that these are all areas, this would be like the area from x equals 0 to x equals 2. This would be from 2 to 3, and this would be from 0 to 3. So you can imagine that the area from 0 to 3 should be equal to the area of 0 to 2 and 2 to 3 added together. So let's see if we actually get that. That's what we believe it should be. First of all, the integral of x cubed minus 4x is, that's an easy one, right? It's x to the 4th over 4 minus x squared over 2 times 4. So if we simplify that, it'll be x to the 4th over 4 minus 2x squared. And then, like for the first one, we're going to evaluate it from 2 to 0. We will get 2 to the 4th, which is 16. 16 fourths minus, and then 2 squared, which is 4, minus times 2, which would be 8, minus 8. And then if we put 0 in for each of these, we would just get 0, so it would be minus 0. So we have basically 4 minus 8, which is negative 4, right? Okay, so that was for the first expression. For b, let's try to figure, let's see, we use the same integral function. We don't need to find that again because it's the exact same one. Now we're going to evaluate it from 2 to 3. So first we plug in 3, and we get 3 times 3 times 3 times 3, which is 81 divided by 4, minus 2x squared. 3 squared is 9, so it would be minus 18. And then we're going to subtract out 2 to the 4th, which is 16, which would be divided by 16 divided by 4 is 4. And then we put 2 in there, we get 2 squared, which is 4, minus 2, which is minus 8. That looks familiar, right? Because it's actually the same as the one we got before. And then we just add up all these. So 81 fourths, that's kind of ugly. We'll just leave that. And then we have negative 4, or 4 minus 8, which is negative 4, negative of a negative 4, which is plus 4, negative 18 plus 4, which is negative 16, negative 16. And then 81 divided by 4, which is, that would be about 20.25. 20.25 minus 16. So that would be about 4.25. Okay. And then finally, we're going to do the same integral, definite integral, except now we use the limits 3 and 0. So first we put in 3 into this expression, and then we subtract when we put 0 into the expression, and so we'll get 3 to the 4th, which is 81 fourths, minus, and then this again is going to be minus 18. And then we're going to put 0 in for both those. We just get 0. And so again, we're going to get, let's see, 20.25 minus 18, which is just equal to 2.25. Okay, so now let's check. Is 2.25 equal to it should be equal to this plus this, and that is not true, right? Because negative 4 plus 4.25 is 0.25. So there's an error here somewhere. I see where I made my mistake here. 4 minus 8 is negative 4, right? And this negative makes it a positive 4. If I add positive 4 to negative 18, that is going to be negative 14, not negative 16. So this is going to be a negative 14. And then negative 14 plus 20.25 is going to be 6.25. So, okay. Now if I add up these two green ones, 6.25 and negative 4, I should get 2.25. And that will give me the orange one. So, yeah, it does show that if I take a definite integral of a function from 0 to 2, and then I add it to the definite integral from 2 to 3, that will be equal to the same thing as going from 0 to 3, in one shot. Okay? So we just kind of showed that. Alright, number 5. Evaluate the following and check with your graphics calculator. So the first one, it says find the integral from 0 to 1 of x cubed. Now that's a pretty easy definite integral to find. It's x to the 4th over 4. We're going to evaluate it from 0 to 1. We plug in 1 and we'll get 1/4. We plug in 0, we get 0, so we subtract that and we get 1/4. Now let's try to do that with the calculator. We're going to put the function, the original function, x cubed, and you don't put in the integral function, you put in the original function. So you put x cubed, and then you're going to integrate it from 0 to 1. So you're going to go, you can even graph it if you want to first. You know what that looks like, right? And then do second calc, and you go to integral, and then you have to say, hey, I'm going to integrate from 0. So you say, is your lower limit, let's see, we'll put in 0, enter, and then we'll put in the upper limit as 1, and it says the answer is 0.25, and that is correct, right? Alright, let's do C, e to the x. So the derivative, or the integral of e to the x is just e to the x. If we evaluate it from 1 to 0, first we put in 1 and we'll get e to the 1, then we put in 0 and we get e to the 0, which is just 1, so our answer is e to the 1 minus 1. E to the 1 is about 2.71 minus 1, it would be about 1.7. So let's test that out with our calculator. We're going to put in e to the x, which is here, e to the x, and then we're going to do second calc, and we will do the integral, and we're going to do the integral from 0 to 1. So we're going to put lower limit 0, upper limit 1, and it tells us it's 1.71. And it even colors it in for you. There you go. Yeah, that's exactly right. Okay. Do you see how it goes from x equals 0 to x equals 1? Exactly. It colors in the shape that you're finding the area for. Okay, and then moving on to E. So let's rewrite this as a, let's see, 3 to the x to the negative 1/2. That looks a little bit better. Okay, and now let's find the integral function. There'll be x squared over 2, and then minus, ooh, that's pretty ugly. It'll be, we add 1 to the exponent, so it'll be x to the 1/2. Then we multiply by the inverse, 2, so we get negative 6, okay? And then we're going to evaluate that going from 1 to 4. So first we put in 4. We got 4 squared. 16 divided by 2 is 8, minus, and then we put 4 in there. Square root of 4 is 2 times 6, which is 12. And then we do the same thing with 1. We plug in 1, and then we'll get 1/2 minus, and then square root of 1 is 1, so minus 6. And so let's simplify that. It'll be negative 4 minus 1/2 plus 6. So 6 minus 4 is 2, minus 1/2 is 3/2. So let's try that one. The function is a little bit harder to input. It's going to be x minus, and remember you're inputting the function itself, you're not inputting the integral of the function. 3 divided by square root of x, arrow, parentheses, And then we're going to do a second calc integral, which is option 7. And we're going to evaluate it from 1 through 4. I like these little drawings it makes. Oh, look at that. Isn't that interesting? It's part of it's the negative. Part of it's a negative area, and part of it's going to be a positive area. Those kind of cancel each other out partially, and it gives you 3 halves, which is what we thought we would get. G is not so bad. G, if we're going to find the integral function of that, it's just going to be log x, and then we're going to evaluate, let's see, it'll be log 3 minus log of 1. Let's see, if we want to like figure out what that is, we have to use the calculator to figure out what that's going to give us. It'll be natural log of 3 minus natural log of 1. Natural log of 1 is just 0, but okay. So 1.098, which is 1.10. 1.10, and then we're just going to confirm using the second calc integral function that is correct. So we're going to put the function is 1 divided by x, and then we're going to go second calc 7, option 7, and then we're going to put in the limits, which are going to be 1 and 3. So the lower limit is 1. And the upper limit is 3. And so the answer is 1.0. It's exactly right, 1.10. Alright. Moving to I. Now, we cannot take the integral of something that's, so complicated. So the best thing to do is do FOIL and expand it first. So if we do FOIL, we'll get e to the negative 2x plus 2e to the negative x plus 1, and then if we find the integral of that, this is pretty easy to find the integral of this. It would be e to the negative 2x divided by negative 2 plus e to the negative x divided by negative 1, or just put negative 2 like that, and then plus x. And, one thing you might have noticed is when I'm taking the integrals here, I'm not putting the integration constant plus c ever. And the reason why is when you take the definite integral, you don't need the integration constant. Okay? If you did take the integration constant, you can see that you would just have the integration constant minus the integration constant, so it would just kind of disappear anyway. So first we'll evaluate it with 2, so it would be e to the negative 4 divided by negative 2 plus negative 2 e to the negative 2 plus 2. And then we would evaluate if we plug in 1, so it would be e to the negative 2 divided by negative 2 plus negative 2 e to the negative 1 plus 1. And we'll need the calculator to figure that out too. It would be, let's see, I'm going to type all this in and I won't bore you by making you watch me. Okay, good thing you weren't watching that because that took a really long time. You just need to be careful of a few things when you type this in. If you want to, you could put parentheses around here, but since I know how PEMDAS works, I know that it's going to do these divisions before it does the subtraction, so I'm okay with the way I put it in here. Now the negative sign here is not a subtraction, it's the negative sign here. Okay, so be careful with that. I just typed it in exactly as you see here. Okay, and then I'm just going to enter, and it gives me 1.52. Okay, and then I'm going to do the alternate method to do this, which would be I'm going to put in this function e to the negative x plus 1. I'm going to put it in exactly like that because the calculator doesn't care if it's easily integrable or not, because it's not really taking the integral. It's doing that method that we used on page 1 and 2, where it's like slicing it up into little rectangles. Oops, I'm doing it wrong. E to the negative, I don't need to do FOIL. E to the negative x, e to the negative x, and then I add 1, and then I square it. And that's it. Okay. And then I'm going to do a second calc, option 7, and my limits are going to be 1 and 2. Lower limit 1, upper limit 2. And then a nice little picture, and the answer is 1.52. Hey, what do you know? That's exactly what I got, right? Alright, you can see how fast it is to do it with the calculator. Can you imagine that they're going to give you some of these on paper too? Last of all, K. So this one does not look too bad. The integral for this would just look kind of like this. I might need to adjust it for the chain rule. Maybe I'll put a negative here. If you take the derivative of that to check, and so e to the derivative of e to the 1 minus x is e to the 1 minus x times negative 1 because of the chain rule. So then you just, hey, look, it worked. Okay? So we got the antiderivative, and then we're going to evaluate it from 0 to 1. So first we're going to plug in 1. We get e to the 0, which is 1, so we'll put negative 1. And then we put in 0. We'll get e to the 1 minus 0, which is e to the 1, which is 2.71. So it's minus 2.71, which is basically equal to negative 3.71, right? We didn't even have to use our calculator. Now we're going to do the calculator method, and we're just going to write in this function here, e to the 1 minus x. Again, make sure you put in the function itself and not the integral of the function, because the calculator does not want to know the integral. In fact, the calculator can take definite integrals of things that you can't even integrate. So that's actually when you're going to use it most. If you can't integrate it analytically using, traditional math methods, that's when the calculator excels. Lower limit is 0, upper limit is 1, and we got 1.71. So I did something wrong here. What did I do wrong? Because do you see how I need to do a minus of a negative e to the 1? So it would actually be plus 1, right? So this would be plus 1, and this would be 1.71, which is what we got there. Actually, it'd be 1.718, so it's actually 1.72. Alright? Alright. Last one on this page. Use the identity sine squared equals 1/2 minus 1/2 cosine 2x to help evaluate this definite integral. So, because we can't directly integrate sine squared, it's too complicated. It's a trigonometry function inside of a power rule. We can't do things that complicated. Okay. All right. So let's substitute. Instead of sine squared, we're going to have 1/2 minus 1/2 cosine 2x, right? And then we're going to integrate that from 0 to pi over 2. So the integral of 1/2 is x over 2. The integral of 1/2 cosine 2x is going to look something like this, sine of 2x. But not exactly, right? And we do have this coefficient negative 1/2 in front. Now what if we took the derivative of this just to see what it would turn out to be? It would be negative 1/2 cosine 2x times the chain rule of 2. So it looks exactly like what we want, except for we need to cancel out this 2 that comes out of the chain rule. So we need to divide by 2, and then it'll be fine. So let's divide by 2 here. So now let's simplify. We'll have I'm sorry, that's not. This is actually the integral itself. So okay, so let me simplify this. We're going to have x over 2 minus 1/4 sine of 2x. And then we're going to evaluate it from 0 to pi over 2. And so first we're going to plug in pi over 2. So we'll get pi over 4 minus 1/4 times sine of 2x. Sine of 2 times pi over 2. 2 times pi over 2 is just equal to pi. So it's sine of pi. Then we subtract off, if we put 0 in for everything, so that would be 0 divided by 2, which is just 0. And then we'll do negative 1/4 sine of 0. Sine of 0 is 0, so the whole thing is just 0. So actually, when you plug in 0, you don't get anything. So, all right, so we have pi over 4 minus 1/4 sine of pi. Sine of pi, that is 0 also. So actually, the answer is just pi over 4. Okay, and that's it for this page.